All right, let's dive into this, huh? We're taking a look at an essay today by Yorgori Schneeppert
Oh,
called
yeah.
QTNs, Quantum Transformer Networks for Chi-I Revolution.
Okay.
He's looking at this really interesting intersection
Yeah.
of quantum computing and AI, and specifically how they could
Mm,
completely change the way we approach solving problems.
right.
It's pretty dense stuff.
Yeah.
Um, but he makes a really compelling case, I think.
What I found interesting is how he frames the current, limitations of AI.
Right.
We're seeing incredible progress with models like
Yeah.
BERT and GPT,
Right.
but they're really pushing the boundaries of what traditional computers can handle, almost like we're hitting this computational ceiling.
Yeah, it's like we're
Yeah.
trying to run a supercomputer on a pocket calculator.
Exactly.
So where do we go from here?
Yeah.
Schneeppert argues that quantum computing could be the answer.
Right.
But I have to admit, the whole concept of quantum mechanics still feels a bit like science fiction to me.
It does have that kind of mind-bending quality to it, doesn't it?
Yeah.
But these principles, like superposition and entanglement, they're very real, and they're revolutionizing the way we think about computation.
Okay, so remind me again, how does this quantum stuff actually work?
So imagine a computer that can be in multiple states at once.
Okay.
Instead of just a 0 or 1, that's
Mhm.
superposition.
Right.
And it allows quantum computers to perform these calculations in parallel,
Okay.
exploring a vast number of possibilities simultaneously.
So it's like having millions of processors
Yeah.
working on the same problem at the same time.
Kind of, yeah.
That's insane.
It is. And then there's entanglement,
Okay.
where you have two quantum bits or qubits
Right.
that are connected in a way that allows them to influence each other instantly regardless of distance.
Whoa.
Yeah.
Okay.
It's a very strange phenomenon, but it's key to unlocking the power of quantum computation.
So I see how this could lead to some major breakthroughs.
Yeah.
But where do quantum transformer networks fit into all of this?
Well, Schneeppert sees QTNs as the bridge between these two worlds.
Okay.
The powerful adaptive learning of transformers and the raw computational power of quantum computing.
So they combine the best of both worlds.
Exactly.
Okay.
Transformers are already incredibly good at processing sequential data, like language.
Yeah.
They use this self-attention mechanism to understand how different parts of a sentence
Okay.
or a text relate to each other,
Right.
which is crucial for things like translation or text generation.
But those processes require massive amounts of computing power, right?
Precisely, and that's where quantum computing comes in.
Okay.
QTNs could leverage these quantum properties to potentially accelerate these processes, allowing AI to tackle even more complex language tasks.
That's fascinating, but I imagine there are some serious challenges in actually building these QTNs.
Absolutely.
Can't be as simple as just swapping out a classical computer for a quantum one.
You're absolutely right. Building a stable QTN is a monumental task. Yeah. Quantum processors are still prone to errors, and the number of qubits available is limited.
Yeah, okay.
It's almost like trying to build a skyscraper with tools from the Stone Age.
So we have the blueprint,
Yeah,
but lack the construction materials.
perfect analogy.
Okay.
But Schneeppert does outline some potential solutions.
Right.
He believes that hybrid systems
But
that combine classical and quantum components are the most promising path forward.
a sort of best of both worlds approach.
That's exactly. He suggests that classical computers can handle tasks like data pre-processing and post-processing,
Okay.
while the quantum part focuses on the most computationally intensive operations.
That makes sense.
Yeah.
So even though we face these technological hurdles,
Yeah.
Schneeppert is optimistic about the future of QTNs.
He is. He envisions a future where QTNs revolutionize fields like natural language processing
Right.
and drug discovery.
Uh-huh.
Imagine AI that can translate languages seamlessly,
Wow.
write compelling narratives, even help us decipher ancient texts with unprecedented accuracy.
That sounds incredible.
Yeah.
And what about drug discovery?
Yeah.
How would QTNs change things there?
Well, one of the biggest challenges in drug development is simulating the complex interactions between molecules.
Okay.
Requires a staggering amount of computational power, often limiting the pace of research.
And quantum computers could handle that much faster.
Potentially.
Right.
Schneeppert argues that QTNs could accelerate the process significantly, leading to the discovery of new drugs and therapies at a much faster pace.
So we're talking about curing diseases,
Yeah.
finding personalized medicine.
Right.
It's almost overwhelming to consider the possibilities.
It is.
But I have to wonder, with such powerful technology, are there risks involved?
That's a critical question, and one that Schneppat addresses directly.
Okay, I'm all ears.
He argues that alongside technical development, we need to consider the potential societal impact of QTNs.
Right.
He emphasizes the need for careful consideration, open discussions.
And proactive strategies to guide the ethical development and deployment of this technology.
So it sounds like we're stepping into uncharted territory here.
Yeah.
A place where the lines between science fiction and reality are blurred.
That's an apt description.
Yeah.
And as we move forward, it's crucial to remember that the future of QTNs is not predetermined.
Right.
It's a future we have the power to shape.
It's a heavy responsibility.
Yeah.
But one that I find incredibly exciting.
It is exciting, isn't it? Schneppat's work reminds us that we're living in this era of unprecedented technological advancement.
Yeah.
An era where seemingly impossible ideas are becoming reality.
I'm eager to delve deeper into Schneppat's vision.
Okay.
What else does he have to say about the potential applications and the challenges ahead?
Well, let's explore that in more detail.
Okay.
He outlines some fascinating possibilities,
Right.
but also offers some practical suggestions for how to navigate the complexities of this emerging field.
All right, let's dive in.
Okay.
I'm ready for part 2.
Okay, so we've established that QTNs hold immense potential.
Right.
But let's get a little more concrete. Schneppat talks about specific applications.
Yeah.
What stuck out to you?
One area that Schneppat really dives into is the potential impact on scientific discovery,
Okay.
particularly in fields like medicine and materials science.
Yeah.
He argues that QTNs could revolutionize our ability to simulate complex molecular interactions.
Something that's currently a major bottleneck, right?
Exactly. It's incredibly computationally intensive,
Well,
even for supercomputers.
Right.
But QTNs, with their ability to exploit these quantum phenomena, could theoretically perform these simulations exponentially faster.
So we could potentially design new drugs,
Right.
predict the properties of novel materials,
Yeah.
even understand biological processes at a level of detail that's simply impossible today.
Precisely.
Right.
Schneppat even points to the possibility of personalized medicine,
Okay.
where treatments are tailored to an individual's unique genetic makeup and specific needs.
That's incredible.
It is.
But it sounds like we're still a ways off from seeing these applications in reality.
Sure.
What are some of the roadblocks Schneppat identifies?
Well, he acknowledges that the technology is still in its infancy.
Okay.
One of the biggest challenges is building quantum computers that are stable and reliable enough
Right.
for these complex tasks.
We touched on that earlier, the issue of noisy qubits.
Right.
And limited scale.
Right.
Yeah.
Schneppat suggests that we need to focus on developing more robust quantum hardware.
Okay.
And that's where a lot of research is currently directed. He also highlights the need for better algorithms,
Okay.
specifically designed to harness the power of quantum computers.
So it's not just about building bigger and better quantum computers.
Right.
It's also about figuring out how to program them effectively.
Exactly.
Right.
Schneppat argues that we need a new generation of algorithms that can take advantage of quantum phenomena like superposition and entanglement. He sees this as a critical area for future research.
It sounds like a massive undertaking.
It is.
Something that will require collaboration across multiple disciplines.
Absolutely.
Yeah.
Schneppat emphasizes the need for interdisciplinary collaboration between physicists, computer scientists,
Right.
mathematicians, and engineers.
Right.
He argues that this convergence of expertise is crucial to unlocking the full potential of QTNs.
That makes sense. It's such a complex field.
It is.
It would be impossible for any one person to have all the answers.
Exactly.
Yeah.
He also stresses the importance of international collaboration.
Okay.
Schneppat believes that the development of QTNs is a global effort, requiring the sharing of knowledge,
Right.
resources, and expertise across borders.
It's fascinating to think about the potential of this technology to bring people together from all over the world
Yeah.
to work towards a common goal.
It is, isn't it?
Yeah.
And Schneppat reminds us that this collaboration is not just about technical progress. It's also about ensuring that QTNs are developed responsibly and ethically.
Right. So even though we're talking about a future that seems ripped from the pages of science fiction, we need to ground these advancements in a framework of ethical consideration.
Exactly.
Yeah.
Schneppat argues that we need to start thinking now about the potential societal impact of QTNs and establish clear guidelines for their development and deployment.
This brings us back to that idea of shaping the future.
Yeah.
It's not just about passively observing technological progress.
Right.
It's about actively guiding it in a direction that benefits humanity.
That's a key takeaway from Schneppet's work.
Okay.
He's urging us to be proactive, to engage in open dialogue about the potential benefits and risks of QTNs, and to ensure that this technology is used for good.
It's a weighty responsibility.
It is.
But also an incredible opportunity.
It is.
Yeah.
Schneppet's essay is a call to action, a challenge to embrace the possibilities of this new era, while remaining mindful of the potential consequences.
It's inspiring to think about the potential breakthroughs that could emerge from this field.
Yeah.
But also humbling to consider the ethical questions we need to address.
It's a delicate balance, isn't it?
It is.
But I think that's what makes this such a fascinating and important topic.
Yeah.
Schneppet's work has certainly given me a lot to reflect on.
Me too.
Yeah.
I'm ready to hear what final thoughts Schneppet leaves us with.
Okay.
What's his overall message? So we've covered the potential applications, the technical challenges, and the ethical considerations. What's the overarching message Schneppet wants to leave us with?
Well, Schneppet's essay isn't just like a dry analysis of QTNs. It's a call to action. It's an invitation to participate in shaping the future of this technology.
I'm sensing a we're all in this together kind of vibe.
Exactly. He emphasizes that this isn't just a matter for, scientists and engineers to grapple with.
Okay.
The implications of QTNs are far-reaching. They touch upon fields like ethics, law, economics, even philosophy.
So it's not just about building these systems.
Right.
It's about understanding how they'll fit into our world, how they might change our lives.
Exactly.
And how we can ensure they're used for good.
He argues that we need to start having these conversations now,
Right.
while the technology is still in its early stages.
It's like laying the groundwork for a future we can all be proud of.
Exactly. And he's particularly passionate about the need for public education and engagement.
All right.
He wants people to understand the potential of QTNs,
Yeah.
but also the risks involved.
Because an informed public is better equipped to make decisions
Right.
about how this technology is developed and used.
Precisely. And he sees a role for everyone.
Okay.
Researchers, policymakers, industry leaders, and everyday citizens.
Wow.
He calls for this collective effort
Yeah.
to guide the development of QTNs in a responsible and ethical direction.
I appreciate that Schneppet doesn't shy away from the big question.
No, he doesn't.
He acknowledges the concerns that people might have about job displacement, algorithmic bias, or even the potential for misuse.
Yeah, he doesn't offer easy answers, but he encourages us to engage in these difficult conversations, to weigh the potential benefits against the risks, and to strive for a future where QTNs are used to enhance human life, not diminish it.
This deep dive into Yorgo Schneppet's essay has been an incredible journey.
It has.
We've explored this cutting edge of AI and quantum computing.
Yeah.
And we've grappled with some really profound ethical questions.
It's been a thought-provoking discussion.
It has.
And I hope our listeners have gained a deeper understanding of the potential and the challenges of quantum transformer networks.
It's clear that this is a field that is rapidly evolving.
Absolutely.
With the potential to reshape our world in ways we can only begin to imagine.
Schneppet's work serves as a powerful reminder that we're not just passive observers of this technological revolution.
Right.
We have the power to shape it, to guide it.
And to ensure that it serves the best interests of humanity.
As we wrap up this deep dive, I'm left with a sense of both excitement and responsibility.
Yeah.
The future of QTNs is full of possibilities.
It is.
But it's up to us to make sure those possibilities lead to a better future for all.
Well said. The journey into the world of quantum AI has just begun, and we can't wait to see what discoveries and innovations lie ahead. Thanks for joining us on this exploration.
Until next time, keep exploring, keep questioning, and keep pushing the boundaries of what's possible.